Hi all, I'm Nazhim Kalam and this is my final year project which is titled as GenSum and I am a computer science student. So GenSum is a novel approach for adaptive generalized text summarization using optimized transformers. So the outline of this presentation will be as follows. We'll be covering all of this, starting off with the problem background and the domain. The problem domain for this project lies in the movie review summarization, and under the research papers I've looked into during my LR, it's found out that the domain of movies are limiting the performance issue related to text summarization, or also known as review summarization. So the purpose of this is to save customers time in making decisions and also promote businesses to increase their sales. So the research limitation is that mostly traditional machine learning and deep learning techniques were used to address this problem domain in movie review summarization. Therefore, researchers listed this to enhance the performance of the system by using latest approaches. And that's where transformers came in. Transformers were introduced recently in 2017, and it was best known to solve any of the problems. And all the references are attached into the thesis related to the gaps and the domains. Moving on, the research gap and solution. So the research gap here is that use optimizing transformers for abstractive text summarization, creating a novel generalized solution to address all other domains at the same time. So the solution was to create a generalized solution which will be able to adapt to any domain, which can be movies, hotels, restaurants, e-commerce, anything. It will be able to adapt and increase the performance of its system with respect to their domain. So the solution approaches considered here for this project is experimenting top-tier transformer architecture and their datasets for generalization to get the optimal model, and then automating the process of customizing the model with its optimal architecture. So we'll be customizing the model architecture as well as also automating hyperparameter tuning for the training phase of the model with parameters like learning rate, whatnot. And finally, we'll be also addressing model retraining with respect to domain data, where this comes in picture with model generalization. We'll be retraining the new data exposed by the domain users to retrain the model, therefore it increases the performance. So moving on, the existing solutions considered happening now is listed as here, and we can see clearly that GenSum is the only tool which will be introducing domain-specific generalization and also summary sentiment score, which is an additional gap. So it's given that GenSum will be the novel system to address this problem. And yeah, the proposed system architecture. So the given architecture in the diagram is the high-level architecture diagram for the system. And you could see the presentation layer, logic tier, and the data tier. The presentation tier will be having a normal UI, a web application UI, where the users are allowed to create a profile, like sign up. Only domain users are allowed to sign up, since we'll be having a specific model just for them. And we'll be also having generalized model where normal general users can use, where they don't need to be domain specific. And we'll be having a UI to input the reviews, and we'll be having a UI to display the summarization, and also we'll be having a buttons to trigger the parameter retuning. So the logic tier, we have user profile creation, and in models you could see that we have two models here. We have the sentiment analysis transformer as well as the generalized summarization transformer model. So since we are addressing both the problems here, so sentiment being an additional extra addition to the project, which is not of high weight, but the main goal of this project is to focus on the generalized text summarization transformer. And we have data preprocessing happening, and then we also are looking into data encryption because we are dealing with business data. Therefore, we need to encrypt them since it needs to be safe while storing the database. So encryption will be looked into. And during model retraining phase, we'll be having to create a new dataset, meaning that For an example, if a domain user has signed into the application, and as he uses the application, for an example, if the domain user is Scope Cinemas, if they sign into the application and once they use the application and input their data, it will be encrypted and stored in the database. And when they want to retrain the model, all the data which they have used will be pulled. This is because each and every domain have different keywords which contribute to the performance of the solution or the model. So therefore, this approach is also considered. Therefore, new data entered by their user will be pulled and then recreating a dataset. So since, for an example, like let's say in the domain of movies, we have cinemas like Scope, PVR, and whatnot, right? So these domains. So basically, Scope Cinemas, PVR, Liberty, all in the same domain of movies, and they have their own data. All those data will be stored in database when they use the application. But when they want to retrain, they will ask the consent that if you want to combine all these data of the similar domain to retrain, because when we combine, we are going to get a large data set. When we get a large data set, the ability to increase the performance will increase because we get new data. So that's also an option. So this applies to not only movie domains, it can be adapted to hotels, e-commerce, restaurants, and etc. So after the dataset recreation, it goes through the phase of hyperparameter retraining. So this phase has two areas. It goes through customizing the model and also finding the best possible parameters for the training phase. So what happens in this hyperparameter tuning layer, in that it basically customizes the model with the best set of number of layers and number of attention heads, number of hidden size, and all those parameters related to the model customization will be done first, and then parameters related to the training phase will be done later on the next. And once all of them are done, we are going to get a highly optimized model, which will be then going through the training phase and then saved into the storage. So this process repeats to any domain and gets adapted to it. So we'll be looking into the demo of the core functionalities of the system. Go through the code. So in the backend folder, we have a folder called datasets, just to list down all the datasets we've used and experimented with. So we use the CNN dataset, GigaWord, and GenSum for the generalization domain. And you can see the hotel and movie dataset. These are two separate datasets used for evaluating the two domains as of now. And we are having the firebase connections since we are storing the data in an encrypted form within this database, and that can be found here. And the models. So we have the base model here, which is the base model given to all the domain users, and for normal general users who do not log in or sign up, considering them as not a domain user, will be using the base model, which is a normal general model, and the domain users will adopt this model and improve its performance with respect to the data. So these models you can see here are the models relevant to 4 domain users. As you can see, 4 models with unique IDs, so they belong to 4 domain users, individual users, and you can see them in the database here. We have 4 domain users, and you can see each domain user has a contact number, email, accessibility, name, and type. So for now, for the project, I just considered few types, which are movies, restaurant, hotel, and e-commerce, which therefore can have so many types like tourism and whatnot. But what's concerning is that what is this is accessible, true and false. So this particular attribute helps to increase the amount of data for model retraining. For an example, since movie is a domain, you can see that I have named this as Scope Cinemas, and we have another domain user with the title of PVR Cinemas. So what's in common between these two is that they are of the same domain. One meaning that they are of type movies, and this is PVR Cinemas and Scope Cinemas. So what is accessible true says that it gives permission to other users to use their own data for model retraining. Since it is in the same domain, but different companies or different businesses under the same domain, they have to give permission to use their data because of their privacy concerns and whatnot. So with this attribute, it handles to make use of their data with other users if only and only if permission is allowed. So likewise, you can see here we have another domain called 3, which is of type hotel, and its business name is Cosman Grad. So that's just an example of the domain and how the businesses are linked with. Moreover, we have necessary constants here, which is dealing with the data preprocessing and whatnot, and we have code for data preprocessing. Model retraining codes is here, and the types, and the main API belongs to this page, which contains all the necessary API routes, and we have encryption because we're doing encryption of the data as well. And let's just run through the routes we have. So we have a general summary route, which just gives the summary disrespectfully as to what domain user it is. If it's a login user or a normal user, it gives the summary as a general user if he does not log in. And we have an API to pull all the records stored in the database. And we have an API to create a specific domain model, meaning that this API creates a specific model for the user. For example, if I log in as a domain, I'll be getting a copy of the base model assigned to me. Therefore, I can retrain my model with my new data and update its parameters automatically and improve the performance. So this is just for the model creation, and this is for the text summarization along with the sentiment and summary and scope for the specific domain. And we have encryption here. This API is just for testing the encryption API, and encryption is implemented where needed. And this API is used to download the CSV data used by the user, and these APIs are used for writing into the database. So this API belongs to model retraining. Once the user hits to retrain the model from the UI, it triggers this API. And what happens here is that using the user ID, it collects the data it has used within the application from the database. And all what happens here is to pull the data and create a dataset. So all data which is given the accessible flag and not will be checked with respect to that and expand its dataset based on the entities and whatnot related to the domain. So once the data is being pulled from database, it's all encrypted. So decryption happens, and once decryption happens, it's converted to a data frame, and then data preprocessing happens. And once that's done, the model with respect to the user ID, which is stored locally in the folder here, will be pulled, and that will be also sent to this function called model customization. So if you go into this model customization, and it's also given that email notifications will be sent while the model retraining happens. So when we go to the model customization, you can see that the normal thing happens here. The preprocessing happens, and it converts the data set into training and test data, and then we perform the model customization. The configuration of the model is checked, and then a group of attention heads, decode layers, drop-off layers, and all those are checked, and it's given, and it's auto-tuned. Basically, it's automated. So we give a range of values where I can check the best of it. So this is for the customization of the model, and here this is for the hyperparameter retraining purpose. For the training phase, you got the hyperparameters which needs to be tuned. That is over here, and this will be using Optuna framework to do the automation. And once that's done, it creates the trainer, and then once we get the best customization results and the hyperparameter tuning results, it's been set to these variables and configurations, and then those are being sent to this function called model retraining. So using the new hyperparameters, which are related to the customization of the model and whatnot, which is initialized over here, will be sent to this, and that will be retraining. So finally, we'll be getting a retrained model, which will be stored in this folder again, meaning that the previous model with the given user ID will be replaced. Moreover, once that's done, the evaluations of the model will be saved into the database. And that's about the retraining process. Moving on, let's just move to the core functionality, which, so out of the three models you can see here, BART, Pegasus, and T5, we found out that BART gave the best performing results. So for the BART base, we performed the customization. And let me scroll up just to go through the customization quickly. What happens here is that we load the data set from the Google Drive, which I have saved, GenSum data set, and we install the necessary dependencies. And we load the data, we do the tokenization over here, and we do the splitting. And coming to the main part, and also this is the rogue score function. Coming to the main part is this. We set the decoder parameters to do an Optuna automated training where it finds the best set of configuration or layers to customize the architecture of the BART, and also do the customization for hyperparameter tuning. And then the final model is saved locally. So once every values are found, it's been set to retrain the model, and you can see the evaluation results. It's on its 80s, which is great. And likewise, the model is saved and the evaluation graphs are being plotted, and all the details, necessary details, are in the thesis. So this is just to give a rough through about the core functionality of the project. This is the UI I have come up with, and this is the area we can use the text for summarization. So initially, if you don't sign in, it is considering you as a normal general user, and we can use any text to summarize. Considering this as a review, whatnot, we can use it to summarize. And we see that we are getting the initial review and the summarized output along with sentiment and the score. So this is using the normal general model or the base model, since we have not signed in. So if we sign in, that means the system considers us as a domain user. So I'll be connecting to a new account just to show that I'm a new user. So it gives a notification that you are a new user, and if you go to the database and refresh, and you can see that there is a new user created with my email, and we can go to the profile and we can update as to what's needed. As for now, we have just listed 4 domains here. You can select whatever you want, and you can give the access type as if you want to give your data to others of the same domain just to retrain it for their retraining purposes. And you can use a phone number, and yeah, you can use a name. Like, since it's movie theater, let's call it Liberty. The user is able to update the profile, and it will hit on the database. So this is the way you register, and once you register, a specific model is assigned to this user. So if you go to the model backend, you can see that there is new model created, this new ID. So that model is belonging to this user, since he's a new user and it's considered as a new domain user. So let me go into the account I already have data with to show how the model retraining happens. So since now I have logged in using my used account, it is the same. You can put your text here and get your output. Likewise, you can also go to handle reviews. In handle reviews, you can see all the reviews which have been used earlier, which you have used, since it's stored in database in an encrypted form. You can handle your reviews from here, meaning that you can delete data from the database, so it will not be considered during the model retraining purpose. So you can delete if you really want. And also you can download all the records needed. It hits the backend and it creates a CSV file with all the records you need. This can be used. This is another simple feature just to save your reviews and to review when you need and whatnot. So let's go back to the model retraining. So here it requests that if you want to use all the other data or just your data. So since this account is connected to a movie domain, if I go, since I have connected this account, okay, and it's under 4. So 4 is the e-commerce domain. Anyways, coming back to this, if you have another account with the same domain like e-commerce, you can select all business data, and if that particular user has given access to use their data, model retraining can happen with their data as well and your data as well. But in this case, since I'm the only user with this domain, I can train it with my own business data. So once I hit my business data, it's going to trigger the model retraining. So let's go to the code, and you can see that it triggers the model retraining. It finds the users from the database, prints out the user details, and it sends an email to the user indicating that retraining has started. Your model is preparing for retraining. You will be notified once it's done, right? So likewise, model retraining happens, and datasets are created, and hyperparameter tuning starts. So hyperparameter tuning and model retraining takes a while depending on the size of the dataset. So likewise, the final model will be done, and it will be replaced with the previous model. And also, the evaluation results will be listed here once done. Since I have tested with a little amount of data, you're going to get bad evaluations. But however, with respect to the data input and the load, the evaluations would increase. So this has been tested with 2 other datasets with a large number of data. So with respect to the amount of data you have, it's going to improve the performance with time. Coming to the contribution to the body of knowledge, this is broken down into 3 areas: the domain contribution, technical contribution, and the additional contributions done to the project. So firstly, looking at the domain contribution, the author was able to increase the performance of the system for movie review summarization using advanced deep learning approaches, which is a novel approach solution we've looked into. And the generalized solution approach considered helps solve similar issues in various other domains. So we have addressed the problem under the domain for movies, and this also can be helped in any of the domain who has a similar problem related to this. And moving to the technical contribution, we've looked into we've covered experimenting top tier transformers and their datasets. Since the top tier transformers we'll be looking into are 3 of them, and also datasets, because with the research done previously, it's given that there are several generalized datasets where they have benchmarked in their papers. So we've taken that and did some combinations and trained with all the possible combinations to get the optimal solution. So experimentation of this is done, and automating the process of customizing the optimal model. Since we are getting an optimal model from the first point, we'll be customizing that. That's also done. And next step, automating hyperparameter search for the face of training model, even that's done. And finally, model retraining with respect to the domain data, which is model generalization, is also covered as the technical contribution for this project. Moving on to the additional contributions, research-based data preprocessing scripts specifically for text summarization were developed. So under the domain for text summarization, data preprocessing is very different compared to the other techniques, because this deals with making sensible outputs. Since if, for an example, if we remove noise from a text sentence, at the end it will make no meaning a sentence, but we have to do more pre-processing to make it meaningful at the end, but with clear text. So research based on data processing is also done for text summarization, and sentiment analysis and score on the generated review summary is also being added as an additional contribution. Experimenting a model with multiple data sets. This consumes so much time, which we have explored with three datasets: XM, GigaWord, and CNN Daily Mail, which are three datasets provided by TensorFlow datasets. We've covered all three to get the best result, and integrating email notifications to inform domain users about the status of the model retraining. So from the demo, you could have seen that when the model retraining is triggered, it's always notified to the domain user on the status of their model when the retraining has been done and what is going on. So those are the additional contributions, and more data or more information can be found in the thesis with respect to the LR problem domain and everything else. So moving on, coming to the research challenge, the author here focused on solving multiple ways of solving the issue. Since we were looking into performance gap, there were many ways on solving these issues in different ways. And this was actually really challenging because of the time frame of the project, because it's a short time frame, and considering that we have to do generalization as well, which is the main goal of this project, to be honest. Interviewers informed that it's kind of risky to take all of them at once, but it's really good if we can pull it off by prioritizing each and every tasks. So yeah, considered that we are doing a domain generalization and we need to be testing at least with two domains to prove that the solution is working. It was time consuming, but yeah, the author was able to complete the implementation along with the reports. And moving on to the evaluation results. So the evaluation results for this are the benchmarking results, which are being displayed here. And the first three, which are not highlighted, are the evaluation results which were done on a general dataset by the previous researchers. With the dataset they have used, we followed the same dataset because it gave a better output. And yeah, as you can see, the previous researchers, the first three is not optimized. Since it's not optimized, the scores they have gotten were in the range of 45s, and we went off. The highlighted result is the author's optimized result. So after all this optimization with the same data set and the same model BART, as you can see, BART 2023 and 2029 BART, you can see the big difference there, that the author was able to get a very improved accuracy than compared to what the previous authors have experimented with. So given that the result shown here gives a clear difference on the performance, hence the solution for GenSum proves that the performance of the model has been increased with respect to the deep learning approaches considered. Moving on to the future work, it is suggested that the transformer hybridization can be used to improve the performance of the text summarization models in the future. So basically, combination of two or more transform architectures also can contribute to the increase in performance. This approach was not taken in this project due to the time frame and the prioritization. Moreover, the author suggests that the including text paraphrase model for user reviews would be a sensible approach, since there is a potential that the user reviews entered are not accurate. So most of the time, when the user reviews have so much noise and improper grammar, this causes the sentence to change its meaning after data processing. So therefore, given that the text initially has proper grammar, would reduce the deviation of making the sense to change its meaning after data processing. So it's best that all the text or words in the given sentence is in proper grammar format before going through any pre-processing techniques. Finally, the author suggests applying keyword extraction for sentiment classification of the reviews in order to identify which keywords contribute to the sentiment classification and to help domain users improve their service. So, yeah, so from the given text, it's currently classified as positive or negative, but it would be better if the keywords which classify the text into positive or negative is also integrated into the system. So that's about GenSum. Thank you.